Well, I'd like to start things off today by thanking everyone for taking the time to attend. I know lots of stuff's going on. I'll introduce myself first off. My name is Lance Zurich, and I'm the product manager for the fischertechnik Education Division over here at Studica. And today I'm going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level involved in things like CTE training, if you're a college professor or an industrial trainer teaching programming skills required in manufacturing, maybe you're with a company that's looking for ways to demonstrate your software-based solutions, or maybe you're just someone who's looking for a way to make IoT-related concepts easier to understand to employees or customers. In any case, I believe this presentation is going to offer some important options for you to consider. And we're going to start off by considering the skills gap. Now, if you've attended any of our other fischertechnik focused webinars, you've probably heard me discuss the importance of STEM education. STEM is, of course, an acronym which stands for science, technology, engineering, and mathematics. And at this point, it should go without saying that STEM education has been perhaps the most discussed topic in education over the last decade. As most of us are aware, the push for developing STEM skills in students is in large part to help best prepare them to take their place in the modern workforce. Not so long ago, when our parents or grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing became more and more dependent upon automated processes and robotic control, employers then desperately needed individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. And as that last point ties directly with the solutions we're going to be looking at in this presentation, let's consider that area of being a PLC programmer. Now, first off, for anyone who may not be familiar with the term, a PLC is an acronym, the letters of which stand for Programmable Logic Controller. And essentially, a programmable logic controller, or PLC, is a very specialized computer used to control the types of machines and automated processes typically found in an industrial setting. And these are going to be things such as an automated manufacturing plant. As the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems grows exponentially. So how much can PLC programmers earn? Well, just to get a clear idea of how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, the average PLC programmer salary in the USA is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year, end quote. Now, as I prepared this webinar, I took a look at a list of current job openings for PLC programmers on nuvu.com. This was at the beginning of 2020. And the listings at that time showed 15 positions being advertised with salaries of over $75,000, two of which listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and the university level. And at the same time as this workforce of tomorrow is getting their training, more and more manufacturing companies facing an urgent need right now are enrolling their incumbent workers into private training schools offering programs like this. So how long does it take to learn? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. But of course, to become truly proficient in all 5 of the most widely used PLC programming languages, which you see listed on the screen now, as well as learning how to efficiently and effectively troubleshoot and address errors and equipment breakdowns, of course, more training would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are, of course, other options available. There's high school CTE training programs, adult continuing ed programs, vocational training, technical training and trade schools, and as we mentioned before, employer-sponsored incumbent worker training programs. Now, that all being said, the question that still arises for the educator, and that's whether you're in the university or the vocational school setting, is how do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you find a way to get away from the dryness of textbooks and video presentations and instead make it more realistic and hands-on? But there are other areas of focus beyond programming that need solutions for demonstrating and exploring and understanding different aspects of automation and control systems. Now, it can be that you're a company involved in creating or marketing a new type of software-based solution. You're looking for ways to make more tangible processes, which might otherwise come across as too abstract, or you want to test out things in a more realistic fashion. Maybe you're with a manufacturing company looking for a way to better visualize the production process for workers or stakeholders as you prepare to build a new factory. Or perhaps you're with a company looking for an engaging way to demonstrate your services and solutions in a public setting, such as a trade show. In all of these cases and more, there's a need for finding a solution that is engaging, which can effectively mimic and simulate real-world automated systems. And that, of course, brings us to the line of fischertechnik industrial simulation and training models. Now, these models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated processes. The line consists of a series of pre-assembled small-scale models, which are designed to replicate in both appearance and function various automated robotic machines and systems commonly found in commercial manufacturing. But before we get into the specifics of the models themselves, we're going to take a little look at fischertechnik. Just to provide you with a little bit of background, fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years, all based around their unique building system. Now, what makes this building system unique is that unlike other popular construction systems where the components are really designed to stack, with the fischertechnik system, it was all created with more of an engineering mindset. The core building block in the system is designed to enable attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Many of the parts used in the system are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of different parts available will also help builders to address very specific design needs. The system itself was created back in the 1960s by German inventor Arthur Fischer, who you see on the screen now, noted for countless innovations used in the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides fischertechnik, Mr. Fischer was the inventor of synchronized flash photography, that was back in 1949, as well as being the creator of the expanding nylon wall plug, which is used commonly in conjunction with a screw or a bolt to help anchor heavy objects to walls. I'm pretty sure we've all used them before. His company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction. They also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Once again, the focus of fischertechnik building sets, and that's whether we're talking about the sets that are intended for the retail market or for classroom use, the focus of these sets has always been on helping to foster an understanding of technology and how things work. Many of the products offered by fischertechnik, specifically for the education sector, are subject-specific sets, meaning that they focus on different STEM-related areas, things like mechanics, pneumatics, robotics, or renewable energy. Now, in many of these sets, students are asked to build a progression of models using the unique fischertechnik system, and then perform various experiments which allow them to explore and understand the various aspects of that subject. There are also sets that are designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. Now, in these project-based learning programs, students dive deep into engineering and learning all aspects of the design process, which requires them to work in groups and create various devices and automated machines to meet the criteria being put forth in a series of real-world style scenarios, all based upon their own trial and error, experimentation, and research. Getting back to the fischertechnik simulation models, though, these are, which are, of course, are the subject of today's presentation, these are something much different. This line consists not of kits, but of a series of pre-assembled small-scale models, which again replicate in appearance and function various automated robotic machines and systems. Models in the Fischertechnik simulation line include things such as conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and even a high bay warehouse storage system. Now, besides these individual models which focus on specific automated processes, Fischertechnik also offers an integrated factory simulation model. This model consists of 4 individual workstations, a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, joined together as one self-contained material cycle. Now, before we begin to look at the models in the simulation line in more detail, let me very briefly outline some of the advantages of using Fischertechnik solutions. I do apologize in advance, as a few of these points are things I've touched upon before, but in each case, I do believe it's worth repeating. First, Fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models are once again designed to realistically replicate, in both appearance and in function, common automated systems such as conveyor belts, sorting machines, robotic arms, and more. Because these models are compact and in most cases tabletop sized, they are not only ideal for use in the classroom or in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. Next, quality. Each Fischertechnik simulation model is a hand-assembled, high-quality, German-made product. Each of these models is available in a 24-volt version designed for use with industry-standard PLCs. Now, it doesn't matter whether you use Allen Bradley controllers, Siemens controllers, or controllers for manufacturers such as Honeywell, Mitsubishi, General Electric, or many others. In any case, you can control these 24-volt models with the PLC of your choice. Likewise, just as you can use your choice of controller, you can also use your preferred programming language from the languages listed on our screen now. Now, please note that with these 24-volt versions, no PLC, unless otherwise mentioned, no PLC is included. And all programming and programming guidance, as well as any power sources or other hardware, are the responsibility of the end user. Of course, this should not be an issue, as these models are designed specifically for industrial users or for those teaching and exploring industrial processes involving PLC programming. In addition, for non-industrial users and for educators not versed in or familiar with PLC programming, there are several models which are currently available in 9-volt variations. These 9-volt versions will ship pre-wired to Fischertechnik's own proprietary robotic controllers, which are the Fischertechnik Robotics TXT controllers. And each controller is pre-programmed using Fischertechnik's own RoboPro graphic programming software. The only additional component required with these 9-volt versions will be the addition of one or more 120-volt power adapters, as I will specify with each model. Otherwise, in most cases, these models should be ready to use right out of the box. Now, if you're involved in demonstrating or exploring IoT, also known as the Internet of Things, besides the fact that many end users have adapted the models that are in the primary line of simulation and training models for IoT purposes, Fischertechnik now also offers a special IoT-focused version of the factory simulation I mentioned before, which is designed specifically for exploring and understanding cloud control and what is often referred to as Factory 4.0. In this case, the model is designed to be both controlled and monitored from a special web-based dashboard. We will, of course, discuss this in detail a little bit later in this presentation. Finally, Fischertechnik simulation models are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options in the marketplace today, you'll notice that the entry point for many of these products can easily be $20,000 to $30,000 or even much more. Fischertechnik simulation solutions, on the other hand, are available at just a fraction of this price, as well as being compact, realistic, and high-quality learning and demonstration tools. So with all that in mind, we're going to get on with our presentation, take a look at each of the models which are available. And I'm just going to get a glass of water here. Because I was running out of steam there. So first off, we're going to start off with the vacuum gripper robot. And what you're going to see in this presentation is a vacuum gripper robot, which has a three-axis robotic model with a vacuum gripping device. This model is designed to precisely pick up and position work pieces in three-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, and a solenoid valve. The dimensions of the model are approximately 9 by 19 by 15 inches, and it has a weight of just about 7 pounds. The 24-volt versions of this model, currently the only ones available, as well as all the 24-volt versions of the first 5 models we're going to look at, each has a relay board for motor polarity reversal and both a multi-pin connector with 34 pins and a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, this 24-volt version, as well as all the 24-volt versions we're going to be looking at in this first section of our presentation, will require you to provide the PLC and the programming, as well as any additional wiring from the PLC to the model, and so on. I will also mention that for this and for the other models that we're going to be looking at today, the specs are also detailed in the product listings found on both the Studica website and the fischertechnik.biz website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. Okay. Moving right along, we're going to look at next the automated high bay warehouse. The model you're going to see in this video features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, along with 9 individual storage spots. Components on this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each. I will mention that this particular model is a favorite among educators I've spoken with who teach programming, and the reason for this is because it gives you a lot to work with in regards to the movement of the picker mechanism, as well as the precision required to properly store and retrieve each piece, each step of which will, of course, require very specific coding. The dimensions on the model are approximately 19 by 28.5 by 15 inches, and it has a weight of just around 18 pounds. Again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you will need to provide your own PLC and programming. And I will mention, as the screen goes white over here, that a limited edition 9-volt version is available at this time, which again is pre-wired to a pre-programmed TXT controller. And in this case, one 120-volt power adapter is required. Next model we're looking at is the multi-processing station with oven. This model features a furnace simulation with a pneumatic sliding door. There is a downstream processing station with a pneumatic transfer unit that includes the vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of just about 11 pounds. Again, the standard version of the model is the 24-volt version for use with the PLC of your choice, with once again a relay board for motor polarity reversal and both the multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And the limited edition 9-volt version in this case is connected to 2 robotics TXT controllers, and because of this, 2 120-volt power adapters will be required for all operation. And next, we're going to take a look at the sorting line with color detection. This simulation features a system for detecting workpieces of different colors, and it sorts them via conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of just about 10 pounds. Now, as with the models we've looked at before, the standard 24-volt version again has a relay board for motor polarity reversal, and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you will need to provide the PLC and the programming of your choice. And in this case, a limited edition 9-volt version is available. And again, this comes pre-wired to a pre-programmed robotics TXT controller. In this case, one 120-volt power adapter is required. We'll just let this go through the sorting of the color pieces. Okay. The next model we're looking at is the factory simulation. And again, this combines the 4 models we've just reviewed, which are again, the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with the color detection into one self-contained material cycle. The cycle we're going to see works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then moved to the multi-processing station with the oven. After the workpiece has been processed by this machine, it is then sorted by color in the sorting line with color detection before being again moved by the vacuum gripper robot to the automated high bay warehouse for storage. Now, as we've discussed the components of each model previously, I'm not going to belabor it by restating them here, but what I do want to discuss are the dimensions of this model as a whole. Now, as it again combines 4 individual models into this one material cycle, because of this, it has a much larger footprint of approximately 39 by 31 by 16 inches, and it has a total weight of between 43 and 46 pounds, depending on whether we're talking about the 24-volt version or the 9-volt version. Now, due to these dimensions, please note that this model will only be shipped flat as freight, and it has to ship on a pallet. And I also want to point out that as the factory simulation models tend to be in high demand, please plan on a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse, and especially with the occasional supply chain issues that we run into these days, which everyone sees. I would just say, to be safe, kind of plan on that. Now, for a few other things to note. First, this is currently available again in the standard 24-volt version and in very limited quantities in a 9-volt version. In the instance of the 9-volt version, it's wired to 5 robotics TXT controllers. And because of this, and because of the way that controllers are connected, you're going to need 3 120-volt power adapters. As always, the 24-volt version will require the end user to provide all PLCs, all programming, and any other hardware required And again, each station of the 24-volt version has a relay board for motor polarity reversal in both the multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the two factory simulations we've just looked at, who may need to transport the model or who wish to protect it when not in use. The travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion of the case is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. I will point out that as much as the cases are standing on their side in this photo that we're using for the presentation, for the purposes of any storage or any use of these cases, you would want to have these laying flat. So the same direction the model is going, you want to store them flat, you want to ship them flat, you want to carry them flat, keep them flat to avoid any damage to the model. Getting back to the case. The case has exterior dimensions of approximately 41 by 33 by 17 inches, and it has a weight of about 53 pounds, and this is without the model in it. So if you put a model in one of these, you're talking about 100 pounds altogether, combination of case and model. Please note that even when using the travel cases, again, you still need to ship these flat. So moving back to more of our training models, the next model we're going to look at is your basic conveyor belt. And this is a transport belt with a length of 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyor belts can easily be connected to increase the length of transport as you may desire. Components on this model include an excess motor, a push-button limit switch, 2 phototransistors, and 2 LED light barriers. Dimensions on the model are approximately 14 by 10 by 4 inches, and it has a weight of just about 2 pounds. As before, the standard 24-volt variation includes a multi-pin connector, but in this case, it's 26 pins with a 2.54 millimeter grid, as shown here. And for a limited time, we do offer 9-volt versions pre-wired to the robotics TXT controller, as shown here. And in this case, one 120-volt power adapter is required for all operations. The next model is a variation of the conveyor belt, which includes a punching machine. This features essentially the same conveyor that we just looked at, but except that this time you have this machining station attached to it. Components on this model will include 2 excess motors, 2 push-button limit switches, 2 phototransistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches, and it has a weight of just about 3.5 pounds. Again, it's available in the standard 24-volt variation with a 26-pin connector and 2.54 millimeter grid as shown here. And for a limited time, we are also offering a 9-volt version wired to the robotics TXT controller, which requires one 120-volt power adapter for use. The next model is the indexed line with 2 machining stations. And this model features a U-shaped conveyor line, as you see here, consisting of a milling and a drilling station and 4 conveyor belt sections. Components on the model include the 4 conveyor belt sections, as I just mentioned. It includes 8 excess motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. And the dimensions of the model are approximately 19 by 18 by 11 inches and has a weight of just about 8 pounds. Again, it's available in the standard 24-volt version with a 26-pin connector and 2.54 millimeter grid for use with PLCs of your choice, as shown here, and in the limited release 9-volt version wired to the pre-programmed robotics TXT controller and requiring one 120-volt power adapter. Next up is a variation on the idea of a pick-and-place robot, in this case the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for this robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or back 90 millimeters, and axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of the model are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. Again, this comes in either the 24-volt version with the 26-pin connector and 2.54 millimeter grid, designed again for the use with PLC and programming of your choice, or in a 9-volt version, which in this case is not a limited availability model, but is a standard model, and it again is wired to a pre-programmed robotics TXT controller and requires one 120-volt power adapter for use. And that concludes our look at the first 9 variations of simulation models. The next pair of simulation models focus on the area of IoT, and these are designed specifically for demonstrating and teaching about cloud-based monitoring and control. These models go by the name of Training Factory Industry 4.0, and again, they are available in both 24-volt versions for use with PLC and 9-volt variations for classroom and demonstration purposes. They've been designed to help address how the recent changes in industrial production, driven by digitization, have created a need for stronger networking and more relevant information on all production levels. With this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a larger scale. Now, as the following video showcasing the 24-volt version provides a nicely narrated overview of how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator. Okay. The following topics can be addressed with the Fischer-Technic Training Factory Industry 4.0. Training and simulation on a realistic production model. In-depth learning through haptic comprehension. Optical and sensory applications. Digital traceability with NFC/RFID technology. Customized production in lot size 1. Integrated cloud connection and control via smart devices using and operating dashboards. Web-based remote maintenance, linking of production and materials planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, this model incorporates many features not found in the models we previously discussed, besides just most notably the use of a cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, enables the position of each workpiece in the cycle to be mapped. And the use of MQTT, message queuing telemetry transport, that allows the networked TXT controllers to communicate with each other. Now, as there are two variations of this model, let's go over what makes them different aside from the voltage requirements. We're going to begin by focusing on the 24-volt version and what makes it unique. First, it is a bit of a hybrid in that while requiring a PLC for the operation and control, it does also incorporate one Fischer-Technic Robotics TXT controller. In this case, the TXT controller serves as the MQTT broker and interface to the Fischer-Technic cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, also known as OPC Unified Architecture, is standard for exchanging data across different platforms. In addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED. This allows the option for not only presenting and using data on a dashboard in the Fischer-Technic cloud, but also being able to display and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC. These, of course, all ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, also known as pulse width modulation. And they also have push-pull output stages for phototransistors and for buttons. Finally, one of the most important new features. Now, unlike any of the previous 24-volt models that I've discussed today, the new 24-volt Training Factory Industry 4.0 also includes access to a sample program. Now, in this case, the program is created in structured text XT format and is created based upon a Siemens S7 1500 PLC, and this program is available for download on GitHub. Of course, the new training factory can also be controlled with other PLC models and brands once the end user makes some small adjustments to the sample program. And the source codes needed for these adjustments are also available for download from GitHub. Now, as with the first of the 24-volt models we looked at today, each of the workstations of the 24-volt variation of the training model Industry 4.0 do have the relay board for motor polarity reversal, and it uses the multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, along with PCB terminals with pushing connections for all inputs and outputs. And all of this information and much more is included in the 152-page PDF manual, which can be downloaded from the Fischer-Technic website, or if you do want access to that, you'll be able to email me at the end of this presentation. You can get that as well. Also, I do see there's a question, wait, is there any manual for these kits available in PDF? How appropriate, it's just what I just answered. Yes, there are some manuals in PDF form. Moving right along, in the case of the 9-volt version, the control is facilitated through the use of 6 robotics TXT controllers. Now, unlike all the other 9-volt versions we've looked at today, these are programmed, the 9-volt version is programmed not using RoboPro, but again, instead using C++. Again, all the programming is preloaded so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF that comes with the 9-volt version, you would be able to get started quickly. The 9-volt version will require the addition of 3 120-volt power adapters. It, of course, requires the ability to access the internet, as well as a tablet or a device for accessing a cloud-based dashboard. Dimensions for these models are approximately 39 by 31 by 16 inches, and it has a weight of approximately 51 to 53 pounds. Now, as with the 2 factory simulation models we discussed previously, we do recommend the optional travel case to help protect your model during transport or storage. And that's the Training Factory Industry 4.0 model, now available in both 9-volt and 24-volt variations. Of course, you might well be wondering how much these models cost, and so we're going to take a quick review of each option I've discussed along with the pricing. First up, the vacuum gripper robot. This is available only on the 24-volt version, and it is $1,010 list price per unit. The automated high bay warehouse in the 24-volt version is $1,159, again requiring the PLC. The 9-volt version with the TXT controller is $1,319. The multi-processing station with the oven in the 24-volt version is $1,010. In the 9-volt version, again with the robotics TXT controller included, is $1,479. The sorting line with color detection in the 24-volt variation requiring PLC, $840 per. The 9-volt version, again with the robotics TXT controller, is $1,129. The factory simulation in the 24-volt version is $4,369, and in the 9-volt version is $5,239. The conveyor belt model, 24-volt variation, is $252 per unit, requires PLC. The 9-volt version with the TXT controller is $519 per unit. The punching machine with the conveyor belt in the 24-volt version is $336 per unit. In the 9-volt version with the, again, the TXT controller, it's $599 per unit. The 3D robot in the 24-volt version is $909, again, requiring PLC. The 9-volt version with the TXT controller is $1,219 list. Indexed line with 2 machining stations in the 24-volt variation, $909. In the 9-volt version, $1,399. And getting right back to the Training Factory Industry 4.0, because of the features of each, they do share the same pricing, whether you're talking about the 24-volt version, which includes the programming, the access to the sample program, or the 9-volt version, which comes pre-wired to the 5 robotics TXT controllers. In either case, you're looking at a cost of $8,235 per unit. But then I throw a wrench in because there are 2 new variations of the Training Factory Industry 4.0 in the 24-volt version that are now available. The differences in the 2, there is one that is basically, and these are both based upon the 24-volt version we just looked at. There is one that has the PLC connectors. Basically, this is the wiring that would go from the model to the PLC. In this instance, that's been done for you. So if you want to get a version that includes the wiring that would connect to your PLC, you would still need to get the PLC. Of course, you're looking at a cost of $11,088 per unit. But if you want a variation that is already connected to a PLC, in this case, a Siemens PLC S7 1500, you can get it pre-connected in the EDU version. You're looking at $16,715 per unit with the wiring and the PLC. The commercial version of that is $18,900. Other items that I've touched upon, the 120-volt power adapters that are used with the 9-volt models and also with the with the version of the Training Factory Industry 4.0 that uses the TXT controller to connect to the internet. In that case, you need a power adapter for that. These are $12.99 each. And the travel and storage case, which can be used for all of the factory simulation and Training Factory Industry 4.0 models that are available. And this includes the ones that would have the PLC or the wiring. In any case, you can get those travel cases for $1,399 each. So on that note, any questions? If you do have any questions, of course, as one of our users already found, there is a question and answer tool on the Zoom toolbar that you can just click on that, open up that window, and if you have any questions, you can type them right in there. I'm going to keep things moving along unless I see anybody come up. So we're going to move right along to taking the next step. So whether you would like to request a full color brochure along with current pricing, we're happy to send that to you. If you'd like to ask any questions directly, if you'd like to request a quote for any of the items you've seen today, or if you would like to speak to your dedicated educational representative, you can call us directly. We're located here in the US in the Western New York area. Our number toll free is 888-561-7521. If you want to email us regarding if you need a quote, if you have questions, what have you, you can email us at info@studica.com. If you do have any questions for me directly over anything that I discussed today, didn't mention today, anything about any aspect of fischertechnik simulation models or fischertechnik period, anything that you might want to ask me, you could email me directly, lance.zurek, lance.zurek@studica.com. Again, if you do want to see the PDF versions of the manuals for these for the industry Training Factory Industry 4.0 models or the regular factory simulation models, those are all available for download right on our website. You could also email us if you'd like access to any of that. And we do have other materials related to these that are available for download as well. So on that note, I would like to thank you all very much for taking the time to attend. We do look forward to hearing from you, and I hope that you have a great day. Take care.